A trapezoid is a quadrilateral with at least one pair of parallel sides. The two parallel sides are called the bases of the trapezoid. The two non-bases in a trapezoid are called the legs. Now, since these two bases are parallel to each other and this leg is a transversal, these two angles are related to each other. These two angles are consecutive interior angles, so they are supplementary. And if we look, this leg is also a transversal between these two parallel lines, so these two angles are also supplementary. A special kind of trapezoid is an isosceles trapezoid. An isosceles trapezoid has all of these properties, and in addition to that, a few more. So an isosceles trapezoid has one pair of parallel sides. These two parallel sides are the bases, and in an isosceles trapezoid, the two legs will be congruent to each other. That's what makes it isosceles. It has at least one pair of congruent sides. In the isosceles trapezoid, these two angles, because they are consecutive interior angles between parallel lines, are supplementary. But only in an isosceles trapezoid, not a regular trapezoid, this angle will be congruent to this angle. And this angle will be congruent to this angle. So if you look, the base angles will be congruent. Our base angles are also consecutive. So in an isosceles trapezoid, our consecutive angles are congruent. If we look at the diagonals of an isosceles trapezoid, from here to here is congruent from here to here, and from here to here is congruent to here to here. So if we look at the overall length of these diagonals, this diagonal is congruent to this diagonal. And if we look at how they are congruent to each other, they don't bisect each other, but they do intersect proportionally. So the diagonals in an isosceles trapezoid are congruent and proportional. Let's look at the midsegment of a trapezoid. Similar to the midsegment of a triangle, if you remember, if we have triangle A, B, C, the midsegment is the segment connecting the two midpoints. And if we know that side BC is 100, side MN will be 50. So the measure of MN is equal to 1/2 the measure of segment BC. Or if we flip that around, the measure of BC is equal to twice the measure of segment MN. if we have a trapezoid, and I'm going to call this trapezoid A, B, C, D, the midsegment has to connect the midpoints of the two legs of the trapezoid. So if I connect M to N, I have a midsegment. And if AB is 50 and DC is 100, to figure out MN, we need to find the average of 50 and the average of 100. Similar to the triangle where we found the average of this side, well, side A is really just a point which has a width of 0, and BC, which has a width of 100, the average of 0 and 100 is 50. The average of 50 and 100 is 75. So to find the measure of a midsegment of a trapezoid, it is equal to the average of the two bases. Or if I think about it this way, it's 1/2 of the measure of AB plus the measure of DC. The second property of a midsegment. If we have the midsegment of a triangle, it is parallel to the opposite side, which means that we have some congruent angles. Well, these angles are congruent because they are corresponding. So in our midsegment, our corresponding angles will be congruent. When we look at the midsegment of a trapezoid, we already have a pair of parallel bases, and if we draw in our midsegment will also be parallel to the two bases. So we have more congruent angles. This angle will be congruent to this angle, and this angle will be congruent to this angle because they are corresponding.